Thank you for the introduction, Anna, and thank you all for coming to this talk. It's a pleasure to be in Moscow in gorgeous, beautiful weather. I'm going to talk about robot futures and about where I think technology is headed and why society needs to begin having a serious discussion about the future of technology and how it can change society. But I have to start with a story. And, well, let me just tell you the story, and it explains why I wrote the book. This is a picture that I took from somebody's speech about the singularity. It's a picture of Lake Erie, which is a great lake on the border between Canada and the United States. Here's how the story goes. Imagine if you drained Lake Erie, completely dry. And on the first year, you put 1 drop of water in Lake Erie. The second year, you put 2 drops of water in Lake Erie. You know where I'm going now. The third year, you put 4 drops of water in Lake Erie. After 15 years, what do you have? Nothing. You have a very dry lake bed. After 25 years, there's some water in the bottom, but it's nothing like Lake Erie. After 30 years, it's full, completely full. And the number of drops in Lake Erie is equal to the number of neurons in the brain. So at this point, you're supposed to go, wow! So in 30 days, we can make AI, because we can fill up Lake Erie in 30 years. This argument from the singularity crowd is about the idea that because computers are becoming faster exponentially, doubling in speed every 18 months, whatever it is that makes humans intelligent can be mimicked in a fairly short amount of time. And I have some problems with this. The first problem I have with this is the idea of exponentiality itself. The suggestion is the speed of a computer is somehow proportional to how close it comes to being a human. And that's not true. The second problem I have with this is much more major. Whether or not we're able to make robots that are indistinguishable from us in 100 years or 1,000 years, the interesting part is the transitional part between now and then. Because that transitional part is an age during which robots are going to do more in our world and interact more in complex ways with us, and they won't be like us. They'll be dumber than us. And so we face a future of mediocre robots doing a mediocre job of taking over our jobs. And that's the period of time I wanted to write about. So this book is about before Lake Erie gets filled. I'm going to split my talk up into some major themes that represent steps forward 10, 20 years into the future and then beyond. The first one is new mediocrity. Let me go straight into what I mean by new mediocrity. The idea behind the word mediocrity, which is kind of an invention, I've seen a few other people use it, is that the way media is presented to us, and in particular, the way media senses us, is changing dramatically. The thing that you need to learn and know about robotics is that the sensors we use in robotics are improving quite nicely. Not exponentially, by the way, but nicely. And there's a future coming when robots will be able to see our eyes, our lips, our nose. They'll be able to know where you're looking, everywhere. They'll be able to tell if you're smiling or frowning. And there's a little 2001 clip that you could watch sometime, because in that movie, Kubrick has a robot reading somebody's lips. That's coming too. There's researchers working on that at my own university. So there's a future when, from a perceptual point of view, the sensors in our world will all know what our behavior is. They'll know how we're walking. They'll know when we joke and laugh with somebody, and when we're serious, when we're crying, and what we're saying. So what does that mean from a robotics point of view when sensing systems around us can do this thing that until now only humans have been able to do, which is to interpret our behavior at a fairly deep level? I'll give you an example of what it means. It's sort of an absurd example, but it already exists, so it's real. You'll recognize the scene. It's McDonald's. You don't have trucks that big that I have seen here. We have very large roads. And we have drive-in. Do you have drive-in here? Do people do this? Okay. So in America, the car is your home. You live in your car, you eat in your car, you sleep in your car, sometimes. What's going on here is McDonald's will cook a Big Mac. They'll cook so many Big Macs each hour so that when you pull up to the drive-in window, if you order a Big Mac, hopefully there's one that just got cooked. But if they don't serve it to you in 8 minutes, they have to throw it away. So they have to guess how many Big Macs to make every hour based on their prediction for how many people are going to drive up and order a Big Mac. Hyperactive Bob is the name of a software program. And this software program has a camera. It looks at the cars pulling into the drive-in window and into the parking lot. It learns over time which type of car and which type of car owner orders what. So big Chevy Bronco, definitely 2 Big Macs, large fries. Little Toyota Prius, fish sandwich. No kidding, they actually do this. So what's happening? Your behavior is feeding a machine learning system that's perceptually seeing you in your car, deciding what you're about to order, and then sending the order to the short order cook. So you still get your sandwich when you get to the window, but they lose much less money. So your behavior is essentially being mined for profit. Is it bad? Is it an invasion of privacy? Well, yes and no. It's not really invading your privacy personally very much, but it is predicting how you're going to behave. And it's making them more money than it used to. So it's interesting. Here's another example of mediocrity. In the old days, if you were designing a website and you needed a color on your website, what would you do? You'd order the color from a graphic designer. You'd hire a graphic designer, somebody who's gone to an excellent design department, and you'd tell them about your website, about the feelings that you want, the emotions that you want on that website, and they would create a treatment for you. Here's your envelope, here's your stationery, here's your website, here are all the different windows you have with this color treatment and the font treatment that you want. That's graphic design. It's human creativity for the purpose of communication. Well, that's not how Google chose blue. And this cover of my book is a representative of that I painted. So Google had a graphic designer. And they went to the graphic designer and said, we want a new color blue. By the way, I'm talking in an odd way because of translation. I don't usually talk like this. Sorry. Hopefully it works for both languages this way. So the graphic designer came back and said, here's 3 excellent choices of blue. And the owner said, what do you mean 3 choices? We asked for the right color. And he said, yeah, I'm an artist, and these are the 3 best colors, so why don't you choose one of these colors? And they said, forget it. They programmed the computer system to automatically generate 41 colors of blue, spread evenly across the chromatic spectrum. 41 random colors of blue. And every time you go to a website for Google, they would flip a coin, a 41-sided coin. And they choose one of the colors and show it to you. And they can collect 200 million statistics on 200 million people using their website with different colors of blue. Then they can choose the color that has caused the best behavior. And you can define behavior however you want. It could be time on task, how long people spend on the website. It could be number of clicks, maximize the number of clicks. It could be money, maximize for people who spend the most money on the website. That's how they chose the color. I find that fascinating because the idea that used to be an artistic expression of color becomes crowdsourced to you, just like looking at your cars. We decide, by looking at human behavior, what the right choice is aesthetically, by correlating correctness from artistry and communication to a quantitative value that we can measure. That's a pretty big shift. So we're headed into an age when robots will be able to collect information from us. Where by robots, I mean not only these systems online that already do that for you, from Facebook to Google to eBay, but in the physical world. When you're walking down the sidewalk and you look in the window of your favorite department store, do you look at the clothing? Do you see the price and then laugh and tell your friend, that's way too expensive? Or do you look at the price and tell him, that's not bad, if only they had it in green? Imagine a series of cameras that record all of that. And take it a step further. We have interactive advertising coming, like Minority Report. So it's advertising that has a camera built in, and it can present digital ads to you like this plasma screen. This is interesting because when it sees you approach, it can go, I think he likes cameras. I'm going to show him some Nikon DSLRs. When it sees you approach, it goes, he's wearing a nice Lumix GH3. I'm going to show him adapters for underwater photography for the Lumix. So it can customize advertising to each person it sees. And they can do this on millions of people. And as they do this on millions of people, they collect information for every demographic, for every type of person, young, old, richly dressed, poorly dressed. What causes them to pay more attention to the ad? Because remember, the camera's there. They can see your eyeballs. They can see your expression. So what you end up with is a world in which the entire system of marketing is reactive to you and optimized to you massively. So I made a little picture for you to show you where this takes us. Massive surveillance is certainly where we're headed. And what's interesting is, from a robotic point of view, massive surveillance will understand us better than it does now. Today it's used for us as consumers. So primarily our job is to buy, to get an app and use it, to buy something and eat it. And we get agency. We get the power to decide what to do. The transition that we're going to see from a Mediocracy point of view that's interesting is this. Funny transition. Reactive systems will market to us using surveillance. So that marketing will be isolated to the individual. It'll be responsive to you. It'll be designed over time through millions of interactions to make it almost impossible for you not to buy precisely what I have to sell, because I'll message it exactly as you wish to hear. You stop being a consumer, because the way they're doing that to you is precisely by mining all the information that you produce by behaving. You already behave, right? I'm not taxing you, but I'm going to ingest it all. I'm going to use it all to learn exactly how to do this. That's something humans could never do before. And that's interesting because they're not paying you a cent for that consumption of your information. And the interesting oddity about this is, if this becomes really, really effective, then you stop having agency. If they can really nail it as advertisers, then you buy precisely what it has been decided should buy because of whatever they have in surplus in the warehouse. And so in a way, you lose your sense of agency precisely because the world has learned to read you and to push your buttons exceedingly well. Now, from a philosophical point of view, there's some names for this. One name is cognitive labor society. Cognitive labor society. It's a word that economic philosophers use for the idea that the labor we do becomes cognitive labor, our own thinking and behavior, and that will become monetized by industry for profit. A second word for it is disenfranchisement. As you spend more time providing production out, but only in small parts, you lose sight of the comprehensive window of work you're doing. It's as if you work in a factory making one small part, never seeing the whole system. You lose enfranchisement, connection to the wholeness of the object that you're creating, which in this case is markets. I'll give you one final example from this. It's from reCAPTCHA. How many people know what reCAPTCHA is? Okay. Sounds like a lot of people don't know about reCAPTCHA. Let me explain it to you. In America, if I go and buy concert tickets, I have to prove that I'm a human being, because robots will try and buy concert tickets online. So they will show a word that's very squiggled, very tilted. And I have to type the word in, and then I can buy the concert ticket, right? probably those of you who know reCAPTCHA know that those words aren't just randomly generated for you. The New York Times newspaper has newspapers that they're scanning for computers to read. So what they'll do is take the words the computer can't read, and they'll show them to you. And so when you enter in your guess for what that word is, you're helping, along with an army of other people, for the New York Times to digitize that word. Now what's interesting is the New York Times will pay Google to digitize the New York Times. And the marketing agency selling the tickets will pay Google to stop robots. And you will do the work of digitizing the word and sending some money to Google and sending some money to the New York Times, because then they sell the digitized articles. Isn't that cool? Now, a month ago, I went with my wife to reCAPTCHA to buy concert tickets. And it didn't show me a picture of warped numbers. It showed me the picture of the front of a house. And you couldn't see the house number perfectly. It was dim. And it said, what's the number? So what's going on? Well, I guess they've gotten hired by another company, a mapping company, who wants to know the number of every house in every picture. And so now I'm supposed to type in the number of the house so the mapping company knows the number of the house. I couldn't do it. It's interesting that the text, in the case of New York Times, is abstract enough that I could just do it to get the ticket. But I couldn't look at the house and knowingly type the number in, knowing that all I'm doing is enabling them to know something that somebody may not choose to make public in a digital format. It's very odd, isn't it? That's something we're going to see more of. And it changes our relationship to the cognitive labor that we're part of today. So that's Mediocracy. The second topic I have for you is robot smog. You know what smog is. It's this combination of fog and dust that can be potentially harmful. Now, robots are not potentially harmful. They can be quite good, and I'll talk about those at the end. But I didn't write the book to talk about good robots. I wrote the book to talk about potentially negative consequences. So, smog. Something that's interesting about robotics is that the fundamental problems governing the forward progress of robotics have a lot to do with mechanisms, motors, basic analog sensors, circuits, and computation, representations. But this ability to have compact motors that have elasticity, like our arm, that can move very lightly, that you can push on, but they can lift very heavy things. These are very challenging ideas in robotics. And we're just now starting to overcome them after many decades of work. They're still expensive, but that's going to go down quite rapidly now. Now, what happens when you make robots that have elastic, muscle-like actuators? When they're expensive, the Department of Defense pays for them, by the way, not consumer economics. Well, what you get are things like this. This is 8 years ago. So these are much, much better today. It's a four-legged robot being kicked by a human. Now, you don't usually get to see robots kicked around by humans. But you also don't normally see robots that can so elastically respond to being kicked by humans. And now you can. Today, that's in the military world. But it's going to come into the consumer world. And what's interesting is that a 200-kilo robot can run around much faster than you today. In fact, there's one that can run faster than a cheetah, the fastest land animal in the world. So where does it take us as robots aren't simply like software systems? If you think about the smog we have in our computer world, those of you who are old enough to remember computer systems in the days of Mosaic, or a little bit after Mosaic maybe, your entire screen was the thing you wanted to look at, right? The entire screen was the website. Then gradually, maybe the right side had some advertising, and then maybe the bottom got some advertising. Then maybe you got some advertising that flashed across the whole screen, and you had to exit it, remember? And what about if you buy a really nice, big, flat-screen television for your home? Then you go home and you watch something, and the whole corner becomes an advertisement. Why did I get a big screen? I could have masking taped that part. What's interesting about robots is that that idea of invading our fovea, invading what we care about with other things on the side, can come. You can take a walk in the park. Somebody can be running, but they could have the running robot with them. to keep pace, and to make them safe. And their running robot could be a robot this big. What do? You're walking the other way, and there's a runner coming towards you, and a very large robot running toward you. Do you jump out of the way screaming? Do you stand your ground because the robot will go around you? What do? We're not trained in how to deal with these robots. So as they enter our world, at first they'll be extremely unfamiliar. And that design question is really challenging. And what's interesting is, eventually, you won't tell the difference between the robots and the people. But it's not going to be when they're flesh like this, when they're naked. You're not going to see sunbathers on the beach and wonder if they're a robot or people. This is a robot, Petman. Same company, outstanding robot. It can squat, it can stand on one leg, it can walk, it can do all sorts of things. And when it's wearing that suit and moving, it's creepy. It looks enough like a person that you wonder if there's a person inside. So you might start seeing a fireman in a suit. You don't know if it's a robot or a person. You might see heavy equipment moving. You won't know if the person's driving it or if the person's sitting there and the robot's driving it. So there's an interesting boundary question we face as we become more and more challenged in identifying whether the world around us and the agents in our world are in fact robots or people. One interesting thing about research in the United States is that there's a national contest called the National Robotics Initiative Contest, making robots like these, actual physical robots, and the job of the challenge, the contest, is to have robots that can use human tools. So check it out. You could make robotic jackhammers. You could roboticize the valve, the steam valve. They're not doing that. They're making robots that have enough degrees of freedom in their hands and legs to use the tools that we have. Our jackhammers, our backhoe, our trench digger, and yes, our machine gun. That's interesting, because philosophically it suggests the idea that we make essentially everything in our world have multiple aspects of control authority, through human authority and through robot authority. It's a way of focusing the confusion that we can have on the problem, stacking our potential for confusion. Now, what's interesting about robot Smog is that this is the high-end research, the expensive part of the process. That's not what's really fun. What's really fun is to think about what happens when amateurs, when non-professionals, start to use robotic technologies that are becoming ever easier to invent new kinds of robots for society. I don't know how many of you heard about this, but as you know, 3D printing is becoming more and more prime time. And that's, I believe, the first working gun made on a 3D printer. It started a really interesting debate. If 3D printers can be purchased, and you can make a gun with a 3D printer, does that mean you can't buy 3D printers anymore in places where guns are outlawed? Well, no, you can buy them still. But it's an interesting problem, right? As we have the ability to create from basic mini factories, we lose control of our ability to regulate. I'll give you one more example of that, and then move on to the next topic. How many people are familiar with this robot? Oh, good, this will be new. This is called BumBot. A guy named Rufus Terrell returned from war, and he bought a pub, a bar. He wanted to make it an Irish pub in Atlanta, Georgia. So the problem he had was a number of homeless people would sit on the sidewalk in front, because the pub was right on the edge of a rich and a poor neighborhood, right on the boundary. He didn't like this. He was not a roboticist, but he read Make magazine, and he got his old smoker for making smoked meat. And he got a high-pressure water cannon, and he got a floodlight, taillight from a car, and parts for building remote control cars, high-power remote control cars. And he built himself a remote control telepresence water cannon with lights. So he would drive up the sidewalk and threaten the homeless people sitting on the sidewalk with a water cannon. And you can probably imagine what they did. They got up and left. This got a lot of press 2 years ago in America. And all the press it got was about how fantastic it was that somebody can now invent a whole new robot in their basement because it's become so much easier to invent something new. What the press didn't say is, this is interesting. The boundary between ethics and invention is evaporating. People can make anything they want. Then what's to govern how they make something that's ethically appropriate or inappropriate? How do we even have people think about the social consequences of what they make? Which I find interesting in this case. So it's interesting to also think about the early times in the web when Flash came out. And a lot of people used Flash, Macromedia Flash, to design really silly jumping and waving figures on their websites. So you'd go to a website and it was ablaze in little penguins running across the top, right? Penguins and birds. Now those times are past, right? The ethics of design moved on. But we're going to have a new Macromedia Flash world in the physical world. Maybe you'll go to your vegetable garden and there will be 3 solar dancing robots dancing in your beanstalk. And you have to move them off your beans. I don't know. But you may face this weird explosion of diversity in robotics. And it can lead to beautiful things. It can lead to robots that do things that roboticists never thought of. It can also lead to very annoying robots that get in your way when you're trying to relax and have an intimate conversation with your girlfriend. So, third topic, we're halfway done. Dehumanizing robots. So this is about the idea of what happens as people interact with robots differently from the way they interact with people. My first experience with this was when I built a robot at Stanford University. And I turned to pay attention to somebody who had a question about the robot. And my robot was down maybe 1/10 of a kilometer away, moving. And then I looked back, and there was a guy with a large cowboy hat and cowboy boots on, kicking the robot as hard as he could. And his girlfriend had stopped in front of it and was stopping it from escaping. And I watched this, kind of amazing, and I ran, right? I ran to stop them, and as I ran up to them, they saw me running and they started moving away. And he said, "See, honey, I'm smarter than the robot," which is debatable in that case. It's interesting because he would never do that to my child. He would never do that to a dog or a cat. But somehow the robot invited him to kick. What's that all about? And what does it mean when robots do induce that kind of behavior as they become more and more social, more human? That's interesting. So here's an experiment done in New Zealand. They gave a number of people that robot on the right. It follows light, and the flashlight in the middle. And they told people, shine the flashlight and make the robot go around in the room. And people had some fun with it. It was pretty cool. Then they gave people the hammer. And they said, that robot is inferior. Kill it. Kill it. And they counted how many times people smashed the robot with the hammer and how they felt about smashing the robot. This is an actual experiment done in 2002 in our universe. What's interesting about that is people did smash the robot. They'd kind of giggle and smash it. And it goes to demonstrate that they have first seen that it's reactive, like a lobster, right? Reactive to light. But then they're willing to smash something that's physical. So I immediately think of self-driving cars, of course. This is my favorite picture of self-driving cars. The self-driving one is the one in the back. This is how Mercedes tests their self-driving car. It's pretty funny. They have a giant blow-up balloon car. I didn't know there were giant blow-up balloon cars in front of it. So if it hits it, you don't have an accident. So the self-driving car is an interesting example because it's the same machine in the same ecological domain as the machine we have today that humans drive. But the way you treat a real car today is modulated by the fact that you know there's a human being inside of it. You don't kick a car as you walk by. And if you curse at the car, you're actually cursing at the person inside the car. So there's specific times when you will insult a car for a reason. When you're at a stop sign and you're coordinating what to do with somebody in a car, you use hand signals, you make eye contact. What will we do when we are in a world where self-driving cars and normal cars are mixed together. If a self-driving car is trying to park in a parking spot, will you just take the parking spot first? Or will you be polite to a car that has no humans in it? Who will just take the spot? No humans in the car at all. You're trying to go to dinner. You're late. Come on, be honest. Thank you. There's no humans in the car. It can go find another spot, right? The interesting part is what happens over the course of time as we treat self-driving cars differently from human cars. Will it bleed into the way we treat regular cars with humans inside of them? How will the social interaction we have with people change when robots start looking more like people or interacting more socially like people? Those are questions that for urban space matter. Because in the urban space, you're going to be facing interactive technology and natural human technology at the same time. And I believe we don't compartmentalize very well. I believe we'll see a poisoning of the interactions with each species, especially as robots become more human. So this is Ishiguro, this researcher in Japan, and his robot. He calls these robots Geminoids. It's a class of robots that are made to look exactly like their creator. You can probably tell which one the robot is. But, 5 years from now, it'll be even better, right? And this is where I introduce another idea, because he uses this for meetings. When he's here giving a talk in Moscow, he uses the Geminoid to run his group meetings in Japan. So it's there, and he controls it from a special control station here. Now, the interesting question is, he uses this robot today completely in control mode. So he's an authority, right? So if somebody on the other end says something to the robot, they know Ishiguro can hear them, right? It's a vessel. But these robots also need to be able to walk from place to place in the office building. And he wants to program them so that you can click the destination location, and the robot will walk there and say hello to people. But he doesn't want to control it. He doesn't want to move its legs and arms and say hello to people. Let the robot do that. When it gets to the next meeting, then I'll step in and actually have the conversation. So now the same robot is sometimes in the control of a human, which means when you interact with it, you're interacting with a human being. And sometimes it's autonomous, which means when you interact with it, you're interacting with a piece of software. And you don't know which it is. So that's interesting. How will you behave? Will you start treating unknown robots as if they're always controlled by humans? Or will you devalue your relationship with robots until you're sure that there's a human behind them? I don't know. But we're going to face a series of consequential interaction decisions that we didn't face before. And of course, robots don't have to look like humans. You can telephone a company, an aircraft company, to make a flight reservation. And today, Delta Airlines can say, please tell me the city you wish to fly to. And when you answer that question and say, Tokyo, sometimes they take the sound file and send it to a human who says, hi, I'm glad to hear you're going to Tokyo, here's your options. And sometimes the robot takes the word, figures out the right answer, and tells you your options. So when you're talking, you don't even know if the voice, the production of your sound, is actually on its way to a human being or not. And on the phone, as the speech synthesis systems become better, it'll become harder for you to distinguish when you are actually talking to a human and when you're not. Again, an interesting question about the ethics of how we'll relate to robots and people in society. So here's my last negative view of robotics. Then I promise we'll do one that's very positive before I scare all of you away. Attention dilution disorder. There's a disease in America quite common called ADD, which doesn't stand for this. It's about being distracted often, not being able to concentrate on one thing. What's really funny is I was giving this part of my speech last week in a meeting, and during the meeting where I was describing how using smartphones, people are never really paying attention to one thing at one time anymore, because they can be in a lecture and tweeting at the same time. Well, guess what? 2 people in the audience tweeted about the fact that I was saying how you can be tweeting during a conference. That was pretty cool. So the idea here is robotics actually gives us a new kind of affordance for further diluting our attention in a way that's both exciting and scary. So I'll give you some examples. One of the directions robotics is going is telepresence. The idea that, for example, in a hospital that's remote, your doctor can come to the hospital through a robot instead of driving there. And so the doctor's face is showing, and you're visiting with the patient, and the nurse is doing the local things. And yes, they're working on the arm control. Eventually, the robot can take your heartbeat or your blood pressure itself. Or they roboticize your bed, so that as you sit there, the bed can take your heartbeat. They can already do that with accelerometer strips on your back, and it can take your blood pressure. What's interesting about this is that the doctor that you're interacting with is through a robot, and the doctor is in a remote location, which by nature means that their full attention is not on you, because they're physically present somewhere else. That means they could be twiddling a pencil, tying their shoes. They could be checking their email on the side while checking on the patient. It's the same thing that happens to you when you call somebody and you hear clicking in the background, right? They're typing. You go, stop typing, I'm talking to you. Same thing. Telepresence will make that easier. Take it a step further, though, when telepresence is mobile. When the doctor can be walking down the street in Moscow and treating the patient at the same time. When their facial gestures are being measured by a camera and then reconfigured on the computer screen there with an appropriate background, a doctor's office background, not the cars in the back of their head in Moscow. Now they can do a lot more things. They can sit in a cafe, drink a cappuccino. Smart AI can remove the cappuccino. It cannot carry the cappuccino gesture at all. The doctor's looking at you the whole time, interested. And you're sitting there drinking cappuccino and asking the questions and looking at the girls and having a good time. That day is coming. It's telepresence. It's how telepresence will happen. What it will mean is that people can be truly in multiple places at once. But you won't stop at 2 places. You'll keep going. What if you could visit 2 patients at once? What if the robot could ask the questions you're going to ask at first anyway? And after all, you ask the same questions at first. How are you? Are you doing better than last week? It's the same first questions. So while I'm finishing off with this patient, I can super pack my schedule and start on patient number 2 and 3. And maybe when the robot can't answer the question itself, then it asks me for help. Yeah. So I just get involved when my robot can't do its job for me. So what happens is what I call CEO of me. You become a manager. And you can take on more and more existences, robotic existences. So your 170-year life becomes like 300 years of life, because you have 4 robots in 4 places doing your bidding for you. You've become a company, and you're the company president or CEO. We'll go there. The very desire to have mobile technology integrated into our face will drive us in a direction where we can view multiple places at once, express ourselves in multiple places at once. And the best example on the screen, you're too far away to see this, but the baby in the bottom right, the legend says, 6 generations after the introduction of Google Glass. And the baby has been born with eyes that point in different directions. So its right eye looks up and to the right at the screen, and its left eye looks straight ahead. So there's the Darwinian evolution of Google Glass, which I thought was pretty clever, so I put it in there for you. So we're headed in a direction where it will become a desirable station for us to have agents, to have impact in multiple places at once. Today, people who do that are called billionaires. They have personal assistants, right? The personal assistant tells you what to do. Sir, it's time to go to your next meeting. You have to say goodbye now. No, sir, you have to get in that car. We have your schedule over there. Sir, I've already told your next 3 meetings that you're running 10 minutes late. They know. That's the future we're headed to, except we don't need the physical human personal assistant. The robots will do that for us. And people will accept that, and in a way, it will make all of us more productive. The bad news is that increased productivity will become an assumption. Just as it's assumed that when you have a business, if somebody needs you and they email you an important question at 8 at night, you're going to answer them. You're not going to wait till 9 the next morning to answer it. That assumption of connectedness that you'll have to multiple places will increase in all places. And I believe the danger with this, the negative consequence is, it can make more superficial the relationships we have with any one place. So, something to think about. Now the good side I promised you. What can we do? This is a horrible portrait of robotics. The book tries to paint fictional stories every 20 or 40 years forward, combined with nonfiction about the kinds of technologies that are being developed that can take us there. But then there's this question, what do we do that's different from this? And just some simple examples, but all the examples have one theme. I think the theme about robotics that's exciting is the idea of empowerment. The idea of robotics as a technology that can provide for us more sensing and more information that allows us as communities, as groups of people, to make decisions that improve our community, to improve the urban landscape, to improve the social fabric of our society. That, I think, is really interesting. Some examples. Really simple example. This one's already commercial, or it's going commercial. It's called Freedom Lift. One big problem for people in a wheelchair, in an electric wheelchair, how do you use a car? They have to have a special van where you can park the electric wheelchair on the back of the van. The door opens electrically, the wheelchair comes up, then you drag yourself through the middle of the car to the front and get in the seat. It's a very long, very difficult process, and it's embarrassing. This is a robot wheelchair. You go to the driver's seat, and you drag yourself up to the driver's seat. Then the wheelchair, by itself, backs up, goes to the back of the car, and loads itself. Pretty clever, huh? It's got sensors, it detects obstacles, it talks to the car's lift, so the lift comes down to receive it. It lets you know when it's locked in place and you can drive away. Very simple example, but it's an example that actually gives people power. It enables them to be more free. Another really obvious example is robotic prostheses. I always tell people who ask, what's the first big revolution in robot, that we're going to lose our wheelchairs. We're headed toward a world where people that use wheelchairs will be able to walk on robotic legs or exoskeletons, depending on their disease. And that means you'll be able to look at them eye to eye, not like this. And it means you can move around in Moscow, up and down all those stairs, and have a real walk with them. And that's a major change in their quality of life, if you think about the amount of time it takes somebody in a wheelchair to get around a city. This technology is huge. It's called targeted muscle reinnervation. Targeted muscle reinnervation. And it's an interesting concept. It's the idea that by measuring large muscle groups in the human body, we can actually train people to activate different muscular regions of their body to control different motors in a robot. This is a really big deal. Before this, you could make a hook with 1 degree of freedom. And when you pinch your shoulder, the one hook opens and closes, and that's it. Once you can do this, you can have 4, 5, 6, 7 motors on a single robot, and you can learn to simultaneously control all the motors. Now you can do complex motions through space, which means a conductor can conduct, a drummer can hit the drums, all of which require multiple degrees of freedom controlled at the same time. So the interface between robot and human flesh is improving dramatically today. And that's a very exciting development in terms of empowering individuals with robots. I'm going to briefly tell you about another set of projects that are about empowering communities of people. And that's the lab I come from, the CREATE lab. It's about 30 researchers designing new robotic inventions. But they're each designed with a specific community of practice from somewhere in the world, explicitly to empower them for some specific reason. So I just want to give you some examples of what this idea looks like when you do community robotics for empowerment. So my first example is actually about photography. One of the interesting challenges in photography is that in the real world, we have detail that's explicitly important to us. For example, if I'm a wildlife ecologist, when I look at the rainforest, I don't just see a rainforest. I see it as a representation of all the animals, all the plants, the biodiversity. If I'm an architect and I look at a site, I look at the type of soil. I look at the type of ground cover and plants that grow. I don't just look at the picture like a postcard. And the problem with regular cameras is they don't capture that information. They just give you 25 or 30 million pixels, but I need a trillion or a quadrillion. I need lots of pixels. So we made a robot that any camera fits on, and it moves the camera and takes hundreds of pictures with the camera and puts them together into a very, very large picture. That's interesting because it changes what people do with the picture that results. Some examples. This is in Mali. They're designing a new environmental center and water purification site. But they want to be able to design it taking into account the watershed, the river, the slope of the ground, the plants and trees around the area. So they use the Gigapan, the robot here, to take a massive picture. Then they have the town council meeting, where the leaders of the town come together looking at a printed out panorama that has so much detail that they can actually work on the panorama making decisions about the work site, about how they're going to architect the landscape of that zone. Same exact technology in the rainforest. You take a picture of a deciduous forest. In the old days, this group in Canada would take a picture of the forest with a regular camera. Then they would send an army of students into the forest, trampling things on the ground, to count all the spiders and types of leaves, ants, other insects. Now, they take one picture like this, and in the lab, they can zoom in that picture and identify all the insects, spiders, ants, and leaves. So the picture changes the relationship they have to the place, because now they have a record of that place that's explorable, that has hidden within it the information that they will scientifically need in the future. So that's Gigapan. It's an example of what I think of as an empowering technology. Very recently, we did something similar for another kind of information that's hard to understand normally, about time. Time magazine released this for us. It's called Timelapse. If you Google search on that, I'm sure you can get to it. We took every picture of the Earth taken from the Landsat satellites from 1984 to now, and we stitched them together into 1.8 trillion pixel frames. And then we made a movie from it, from 1984 until now. So it's a movie where each frame of the movie is 1.8 trillion pixels. That's big, very, very big. So this movie, while you're playing it, you can zoom in and out. You can go forward and backward in time. To be more general, you can explore in space-time with this movie. So you can go to a place or a time and then explore through a tunnel of space-time and see what happens somewhere. So you can see Moscow growing. You can see Las Vegas, Nevada growing and Lake Mead shrinking. And you can see the correlation between the two. You can see deforestation in the Amazon. And that one is incredible, I tell you. You zoom in and you can see roads being built. And then you can see roads coming off perpendicular to the original roads, like a fishbone pattern. And then the trees disappear. Then you can back away and realize, wait, there's hundreds of roads. Then you can back away and it's thousands of roads. Then you can back away and you realize you can see the eastern and western edges of South America and all the trees are gone. So it allows you to appreciate the scale of devastation, precisely because you can zoom in and see it in great detail. Without detail, scale has no meaning. And it is precisely because of that scale that the detail makes meaning. And actually, you have an anniversary coming up for Gagarin, who said this exact thing from space. He talked about the idea that the detail he got from space of the Earth made him consider geopolitical boundaries differently than he did being on the Earth. You need that massive change in scale. And this is one direction for that. We also work on environmental technologies that are basically massively networked robots that image the world, but not with camera technology. This is a river near my house. You can see maybe some trash in it. This river has so much fecal matter in it that if you step in it and play, you'll get a rash on your skin. Because the sewage overflow system for my city, when it rains, is mixed sewage and water drainage, and it dumps the sewage raw into the river. But people don't know how to measure the water quality. What's more, the rural area around my city and across Central Africa has water quality that's changing dramatically quickly because of drilling. People are doing hydraulic fracturing to pull out natural gas. But when they pull out the natural gas, they bring up salts. And the salts, with bromines and with radioactive chemicals, go back down into the watershed, and then go down into the aquifers, and then the well that they're using to feed their cattle is poisoned. And the only time they find this out is when the hair falls off the cow, or when their own hair is still falling, or they get a rash on their skin. So we wanted people to have an earlier way of measuring this. And more importantly, we wanted people to visualize changes in water quality so densely, so completely, that it's like that picture of the Earth. You can zoom in and over time see the water quality change, correlate it with the changes in industry, and understand how industrial activity is directly impacting water quality. So we made a really simple device, in this case, that has a 5-year battery in it. We call it Flamingo, the bird Flamingo. And it sits in the water and measures every 15 minutes the water quality for up to 2 years to 5 years. And you walk up to the river whenever you want with a little remote control. And you click it, and all the data goes up to your remote control. It's using 802.15.4, Zigbee, for those of you who are electronics engineers. And then from here to the internet. So the idea is then people are empowered to take an inexpensive $100 device, adopt it, adopt their local watershed, measure the water quality, and help create a global map of water quality so that we've actually memorialized the idea of water changes. And we can review it and look at patterns and start to understand what's happening. My last example is the very simplest. The big problem we have in the US is that people have become very literate with technology. They, as babies, know how to go to the App Store and get an app on their mom's iPad and play with it. But you know what they don't know how to do? They don't know how to make an iPad. And they don't know how to program an app. And they rarely learn. In other words, people have become consumers, incredibly refined consumers, because this is what companies have tweaked for us, without understanding how technology works well enough to imagine hijacking that technology and using it for advocacy. And that's a shame. What we want instead is for people to become what we call technologically fluent. Fluent instead of literate. In other words, instead of just knowing how to use, learn how to invent and create something new that nobody's made yet using technology that you can buy. That's fluency. So how do you get people there? Well, step one, start with 4-year-olds. So we started a program in schools in Pittsburgh, and we're going to take it national, with the simplest, smallest pieces of electronics. Blade switches, LEDs, light bulbs, alligator clips, wires. And instead of hurrying through a technology where the children have to build something fast, fast, fast and do a test, with the same few wires, motors, and lights, they spend 6 months experimenting, sketching, drawing, coming up with a language for how it works, then using that language to teach each other how it works. What happens at the end of this process is that they develop an amazing level of fluency about the technology. These children can be challenged with a new toy. They take it apart with a Phillips screwdriver, they open it up, and they can name all the pieces. There's the microchip, there's the LED, there's the switch, there's the light bulb. I bet you the power's going this way. And when you ask them about a toy and why it breaks, they have ideas, they have theories. They develop an internalized language for technology. And you can't do that with a shiny iPad. It's a sealed box that's white or silver, right? You can't see how it works. You don't build an understanding of what's inside of that in miniature. So this idea of slowing down education and using the very simplest technology to infuse in our youngest children the idea that they should be self-confident toward technology, rather than think of it as a magic inside that you don't break, you just use. I think that's probably critical to changing the relationship of power between people and technological artifact, so that every time a new technology is born, we are users of it. Of course, we want more water quality meters and less bum bots, which means somehow people have to have the ethical framework to also think about how you can use technology to better society rather than to create division. That's more challenging, maybe. Okay, my last slide. If you're interested in this whole area of discussion, I wanted to recommend some books to you. So I thought about what I think are the most interesting books. And I don't know if these are available in Russian, but briefly, It's embarrassing to put it on there, but I did put my book on there because 8 is a more even number than 7. Sorry. Race Against the Machine is beautiful. It's a book that talks about how productivity is increasing in companies, margins are increasing in companies, and even as domestic products go up, employment levels are going down now. So automation has reached an interesting tipping point where the level of automation increase has outstripped our ability to replace people's jobs with new jobs. The edge, if you will, of robotics capability is outgrowing the middle class's capability. And that book is really excellent in showing through charts how since the mid-1980s the trend has reversed in a very bad way. Digital Labor is about this idea of the cognitive labor society. It's an excellent philosophical book about what it means for us to do free work on the internet that is the reason for the high valuation of companies like Facebook and Google. It is our work, our consumption and behavior that in fact controls their value. Cultural Boundaries of Science is an excellent cultural book about how scientists make decisions without realizing that the inventions they create have major downstream impact. And it gives some beautiful examples. The one on the right has one chapter that's really good, chapter 6. It's about the idea that big data and raw data is not unbiased. And when companies use it to come to a conclusion about marketing or politics, how they collect the data has a massive implications for what conclusions result from the data. This is by my friend Hans Moravec, Robot. Robot is a book from somebody who's in the singularity. And if you want to read a book from people who do believe they're going to be immortal, who do believe that Lake Erie will fill, and we will all live forever, that's a book that really does an excellent job explaining why he feels that way. Now again, I disagree with him, but he would say if he's off by 20 years, he's only off by 20 years. It's exponential. One way or the other, we're all going to become immortal eventually. Wired for War is about robotics in the military. And Super Crunchers is about how companies are actually predicting your behavior using our behavior. So our behavior has become, in a way, a snake that's eating its own tail, able to predict the future rapidly with more and more effectiveness. And with that, I'm done. So I hope you read some of those books. Thank you for your attention, and we're happy to take some questions.
Well, you have been talking about the ecology and about the methods and robots to measure the pollution. Well, how about to change the situation? Is there any, I don't know, robots to change the environmental problems globally?
There is actually a significant body of work in that area that the National Academies of Science runs. It's called, I think, geoengineering. And it's pretty interesting stuff. They talk about things like spraying certain compounds into the atmosphere, the upper atmosphere, that, for example, will reflect the sun for 20 years, and they'll dissolve over 20 years. And the idea is, if they reflect the correct amount of sun, it'll cool down the planet slightly. There's the idea of spraying water in the ocean. If you put enough jets of water in the ocean spraying up, you can actually change the overall amount of humidity right next to the ocean layer, and that again causes different amounts of rain to fall on land. So there is this idea of geoengineering through different kinds of robots. There's also massive carbon capture equipment. The problem with all of them that I've been able to see so far is that our simulators are not perfect. And when you talk about launching 1 billion tons of mirrors into the troposphere, I have to ask the question, excuse me, what if we're wrong? Can we make ourselves go extinct? So every time we have taken invasive species into a new country, they become rabbits. And they multiply and destroy the local species. So that would be my warning, is that robotic attempts to geoengineer the world can end in disaster. Now we had another question up front here.
So first of all, thank you for the amazing talk. And actually I have 2 questions. Still, we can see a lot of robots around us, right? And even in Moscow, in the United States. And I'm just interested in your opinion. It's always hard to predict, but how much time we still left to figure out the answers to all these questions, right? I mean, it's 5, 10, 20 years or whatever. And the second question is, I'm also interested, you raised a lot of questions, right? But just imagine, I'm, for example, a robotics entrepreneur, right? And I'm just building, any kind of robots. What kind of framework shall I use to solve these kind of issues? I mean, how should I approach, solving all these issues? It is a problem you stayed with, but how one can try to actually solve it?
So let's talk about date, and then let's talk about how to solve them right. In terms of date, an easy place to start is the dates in my book on the fictional stories. The first one is maybe 30, 35, 40 years away, and it's just media, it's just perception. Perception is going to mature much faster than action, much faster. Because of data mining and the way we're doing computer vision today, it's very likely that we'll have excellent abilities to see us all and understand all our gestures easily within the next 15 years. And then beyond that, to market it and to optimize behavior based on feedback loops. So those aren't going to be robots that you see, though. There'll be cameras throughout the world that we already have. So it's interesting. Robots may not look like robots to you for a very long time indeed. Even when they're prostheses, you might have long legs on, long pants on, I'm sorry, so that you're not even aware of how many people have robotic prostheses or artificial knees, for example. So on the time question, I think that the ability of seeing robots, let's say playing ball with your child, playing football in the park, or running with a runner, I think that's at least 40 years away. Most roboticists think I'm crazy, like I'm nuts. I went to a dinner with Rod Brooks and a bunch of famous roboticists, and I was joking about RoboCup, which is a soccer game, where robots are trying to beat humans in, I think, 2020. And I was saying, yeah, that's about as likely as snowball in hell, right? And they all looked at me and said, what do you mean? That'll happen by 2020. And I said, soccer? You think robots are going to beat humans at soccer in 10 years? This was in 2010. And they were all of them, convinced that that was going to happen. Convinced. So I'm peculiar on this. I'm much more pessimistic about the advance of technology, maybe because I'm more mechanically inclined. I'm more in the world of motors and electronics than just AI. So maybe they think that through AI you can solve many of the engineering problems because the robots will become better engineers. That, I think, is a long way away. The second question, how do we do it right? I have a simple answer, and I want to get on to other questions. Simple answer is, every time you fund a company, you need to make sure they have a real anthropologist on board. They have to have real designers on board. You have to force them to listen to the words of a designer who understands sociological design, so that people can design robots in a social framework and create robots that actually will make people more fluent, rather than making us more ignorant of how the world around us works. And I think it's a matter of design. I think excellent companies can do that excellently well. But the capitalists need to actually step up to the plate and force the companies to do it. Because no engineer has taken a single design class or a single ethics class, ever. And so since the engineers don't have the training, when they start the company, they will have none of the intuition for that. In the back. Yeah.
Меня очень задела ваша обложка, и в связи с этим такой вопрос. А роботы смогут соревноваться в творчестве с человеком? Как по вашему мнению?
That's a very good question. Can robots compete in art? So I'm not actually a painter, I'm a potter. I make ceramics. So to make this cover, I actually went in France to the factory where the old artists used to get their oil paint. And my mother-in-law knows oil painting, so she taught me a little bit and I made the cover. Because I wanted to make the point that I, as a human, can mix 41 unique colors of blue using the original pigments of blue that the masters used 200 years ago. So that was kind of very much on purpose to show that. You know, it depends on your definition of the word art, in the same way that a lot of robotics debates are about the definition of the word robot. Robots can perform. There was a Norwegian group that made a robot that performed, and another robot that enjoyed the performance. And so the idea was humans were unnecessary. One robot was the performer, one robot was the one who responded to the performance with a smile, and that was the whole system. You can put them in a room, turn the lights off, close the door, and we can all leave. So maybe robots can do art for robots, I don't know. But if we think deeply about what makes us essentially human, I think there is something crucial about humanity that makes robots unable to reach our level of sophistication in rhetoric, in message making and meaning making. So as far as I'm concerned, no, they can't really do art the way we can.
What is the difference between human instinct and a computer program for some robot? For you, how do you think?
Humanistic and what?
A computer program for some robots that...
I don't know what a humanistic program would look like. But a computer program is like a recipe. It's a set of steps. It tells you exactly what to do. It can be arbitrarily complex. So it can be very difficult to distinguish between the computer program and somebody controlling the robot. But there's no such thing as a humanistic program today. Now, there are people who are trying to write ethical programs for robots, for war in particular. There's a whole group working on robots. This is what they say. They say the robot has guilt. Guilt. And it kills people. And if it accidentally kills an innocent person in war, the guilt number goes up. And when it gets above 100, it stops killing people until the guilt number goes back down. And then it starts killing people again. And when you ask them, why did you do this? They say, oh, because that way is an ethical robot. Again, I remind you, this is somebody who has never read any ethics or Aristotle. They've decided that calling a variable, a 16-bit number in a computer memory store, guilt, and having a threshold, 100, solves the problem. So we're going to see a lot of that. We're going to see a lot of robots that, for instance, simulate emotion. And you interact with them, and they can be happy or sad, precisely because they want that to cause you to behave differently with the robot. So if it's lonely and sad, you might be nicer to it. They're using those to push our buttons. They're not using them because the robot is authentically sad. They're using it because they want our interaction with it to become as if it is sad. And there's that difference. Well, it's epistemology, right? I mean, it's going to be the difference between reality and our vision of reality. Yes?
Yeah, I want to say that we entered an age where everything we say can be recorded and is recorded, and everything we see is recorded and analyzed. But 10 years from now, there'll be so much data. Like, how is it going to be stored for the future?
It's a very good question. Can the data outstrip our ability to store it? The short, sweet answer, unfortunately, is no. we can record it all. The NSA, the National Security Agency in America, we just got all these leaks. In fact, Snowden is in Moscow right now, so maybe he's out there somewhere. No, he's not in Moscow. He was at the airport. I think he's here. Oh, hi, Snowden. Actually, don't show yourself. You get arrested. But he leaked the fact that the NSA actually records every phone call in the US. So they have the memory to do that. The trick is memory, it turns out, is not that expensive for very big companies. And they've built ever larger data centers. What's interesting is the energy we use just to store this information. If you look at some of the data centers we have in the United States right now, some of them use as much power as a town of 60,000 people for a single data center. So we're talking about remarkably large sets of computers with incredible cooling systems. But Moore's law, exponentiality, does keep up with that. So we are going to have ever greater amounts of memory at ever cheaper prices available to record and analyze information. There's a whole study called Big Data that's about this. And it can lead to fantastic discoveries, to correlations between behavior and cancer, for example. But it can lead to marketing, it can lead to invasion of privacy, and it can lead to this idea of property dissipating. My behavior is not my property anymore. It's the property of people who make money by selling it to each other. And I don't get any of that. I don't get a return on that investment.
Скажите, пожалуйста, вот как вы думаете, вот человечество долго шло, сначала оно придумало топоры, потом оно придумало атомную бомбу, и потом появился коллайдер. И постоянно растет прогресс, и в робототехнике тоже. Как вы сказали, уже через лет 5-10 будут играть люди в футбол с роботами. Но военные, я думаю, тоже заинтересуются этими разработками. И киборги, все вот это вот, что появляется кнопка, которая якобы должна быть у киборга, что не навредить человеку, чтобы его можно было всегда отключить. Рано или поздно она тоже, я думаю, будет взломана, и сами роботы могут навредить человеку тоже, в конце концов. То есть как вы думаете, возможно ли это, что человечество может пострадать от роботов и будет своего рода война кибернизированная? Спасибо.
This is a good question because many of the movies we see, Terminator, are about the idea that robots actually destroy people. They decide we're not good enough, and they just kill us all. The question that predates that is, when are robots self-aware? Self-aware enough to make decisions about their own race, their own existence, rather than simply following our code. And the answer to that, my opinion, is it's still forever away. It's way beyond me or my children's children's lifetime. In other words, we're going to see many robots that are very capable. They will cut the lawn, they will go to war, they'll kill for us, they'll save lives for us, they'll do surgery for us. But to my knowledge and to my understanding of how robotics is evolving, we don't have any idea where consciousness comes from. And we don't know how to create a sense of consciousness in a being that's new, or how to download a human's consciousness into a robot. So I think it's possible that even 200 or 300 years from now, in a talk here, with people talking to each other, with maybe more robots flying around, giving us advertising, you still won't find robots that don't listen to the command. that they're given. I think it's very possible we'll still live in that world. The other side of this is very capitalistic, but companies are going to own the robots. And companies are going to be owned by people. And I don't think we're close to a time when robots own capital, when robots own things. So I don't think we're in for an insurrection, because in the end, the owner is going to be a human. They're the one who's becoming the billionaire, and they're going to be in control. The danger we face with robots is that, in fact, robots may be significantly increasing the gap between the wealthy and the poorest by taking away the middle class as they take away the middle class set of jobs. And that's a shame, because the middle class is the most interesting part of the population in terms of people who can be creative and effective in communities.
My question is refers to the question because it's about ethics. Would we accept the sense of rights for robots?
This is a very interesting question about rights and robotics.
Rights, yes.
I have a section in my book about slavery and agency.
Oh, yes.
There's really interesting analysis that we can look at from the days of slavery, in the discussions around slavery. One of the discussions had to do with the question of how we perceive the other. If we see in the other person, the other machine, agency, if we see in them free will of some kind, it doesn't actually matter if they have free will or not. If we perceive them as having free will, we destroy our own sense of humanity if we don't treat them as having the same rights that we have. And this is an interesting formulation that goes to Aristotelian ethics. But the basic conception is that agency is the core of value. And if somebody we see as having agency, we treat them as if they don't have agency, then we take away the inherent value of agency itself. And if you buy that analysis, then even if robots aren't self-aware and they can't declare revolution and kill us all, even if they can't do that, if they're making decisions and have been designed in a way that gives us the impression that they have agency, then we face a world in which abusing them, hitting them with a hammer, is wrong. Not because they have nerve cells and they hurt, but because it's an expression of violence on our part. In the same way that expressing violence on a video game maybe is ethically wrong. Because if the video game is realistic enough, we're showing a kind of behavior that is unethical.
Yeah,
so it's tricky. Good question.
Because for example, nowadays there are a lot of associations for protecting animals, but robots, it's something, I don't know, mediocre between animals, human, and the kind of property.
And this is my problem with robots. You know, if we start abusing robots a great deal, and we have social interaction with them, if we intercourse with them in speech, and we abuse them, it feels to me like this may pollute the way that we think about ethics toward humans. Are we going to really, change abusive, not abusive, abusive? We're going to get it wrong. We're going to not switch quite right, and that can be a shame.
Отталкиваясь от вашей реплики по поводу книги вашего друга, коллеги, Robots, можно ли заключить, что вы скептически относитесь к идеям трансгуманизма, точки singularity, которая будет достигнута приблизительно к 2045 году, и тогда все запутается с развлечением людей и роботов? Спасибо.
Thank you. It's a good question. Yes, you have your own Russian investor, Itskov, who's investing in the 2045 project. The idea, for those who don't know, is that we should create avatars, robotic agents, mass produce them, make them cheap enough, and then we use them to solve some of the world problems, like mortality. So download people's consciousness to them. And he's even talked about world hunger, the idea that once we have an avatar like that, the agency organizations, the AIDS organizations that feed people and send them clothes, instead, they can mass produce the robot avatar, and when somebody's hungry, they can just download their consciousness into the robot, and now you don't have to feed them anymore. So this is something that is talked about in serious circles in transhumanism, in post-humanism. Moravec's idea is that robots are the human's evolutionary consequence. So once they exist, it doesn't even matter for humans to exist, once they're sufficiently intelligent. My feeling is complicated on this, because I respect the people who are working in this area tremendously. They're very famous scientists in many cases. But there's fundamental problems I have. One is exponentiality, the idea that computer speed is sufficient for us to understand how to make an artificial human, I don't agree. Second is the idea of downloading consciousness. There's a general notion here that when computers are smart enough, they will figure out for us how you can take a human consciousness and put it in a robot. And my problem is I'm not sure that our consciousness can be represented digitally. It may be that our consciousness is a pretty complicated chemical analog system that's inherent to our body, and that separating it from a body is impossible. It's possible. So I just am not confident that this will happen. 2045, I would be willing to, if I was a betting man, I would bet very large amounts of money that we definitely won't do it by 2045. I think that's way too early. I think if it actually happens, that we have robots, that we can download our brains to the robot, I think it's probably like 2500 or beyond. So I'd say we need at least 400 or 500 years to do it, even with exponentiality. So that's how far out I am on this. And I don't even buy that quantum computing will get us there. Quantum computing makes certain kinds of things faster, but not chemical neuronal pathways. They don't help with that at all. So that's my opinion. And again, I'm in the minority probably for this one.
Смотрите, вы говорили про то, что есть много мелких интеллектуальных агентов, которые решают специализированные задачи. Вопрос в том, зачем тогда нужны антропоморфные роботы, и есть ли у них будущее?
That's a fantastic question. The robots we're going to see first will disappear into the woodwork. They will not look like androids or people in the least. What will happen is your world, your house will be interactive. It'll become more intelligent. Your smartphone that I don't have will be more interactive with you. Google now has advertised the idea that when you're late to your next appointment, it will call your next appointment and tell them that you're running late. Because it knows you're late, because it knows where you are, it knows where you're supposed to meet them. We're going to see a gradual increase in the way robots melt into our world. If you're going to have robots folding our laundry, they're not going to look like us. It's going to be a big black box that you throw your laundry in, and they come out folded on the other side. So the idea of general purpose robot that is just like a human is a little bit nonsense. It's much cheaper and much easier to mass produce special purpose robots for specialized tasks. You also get people to buy more robots that way, so companies make more money. So yeah, I completely agree with you. The anthropomorphic robot that looks just like us is very unlikely. However, Defense Department is working on it in America. They have a contest for it, precisely because they want robots that can use all the human tools. What they're not saying exactly, but what they mean is that they want the robot to use all the human weapons. Right? They want that robot to throw grenades the way a human does it, to fire a gun the way a human does it, to fly an airplane the way a human does. I don't know why they want this, because you could automate each of those. But in the business world, definitely there'll be special purpose for many years, I think.
Well, my question is, why do you think that people would wish to create an artificial mind with human-like features? What's the point of it? Why don't leave it naked?
There's a few different, yeah, it's more fun making it, probably, than engineering it. There's a few reasons why people try and make it. One reason is there are developmental scientists who want to understand how humans learn. And they actually try and simulate the human brain system and nervous system and test it because they want to learn how learning happens. Sometimes for very pure and excellent intention, like helping an autistic child learn better. So if we understood how humans work better, we can solve diseases, developmental diseases of the brain more properly. So that's one major reason people do it. People study why we dream. They study how we retain memory. Because then if somebody has brain cancer, maybe we can figure out a way to remove the cancerous lesion, but support the correct parts of the brain so that you can still have memory and still be functional. So that's one reason. Another reason is more kind of egotistical. It's to solve the biggest problem we have, which is, can we create life? Right? It's kind of the God syndrome. It's people wanting to show that they can be godlike and create life. People have been trying to do that for a very long time. Mary Shelley wrote Frankenstein about that. And that's never going to stop. So one side of it is very pure, and one side of it is very much about me, about showing how I'm going to win the Nobel Prize for making life for the first time.
Вы нарисовали достаточно такую опасную картину, в которой вполне возможно, что человечество может погибнуть. Да, и развитие робототехники, она не может развиваться без развития новых материалов, без развития новой энергетики, что тоже опасно для человечества. Вот что, на ваш взгляд, более опасно? остановиться сейчас нам в развитии, либо развиваться дальше? Спасибо.
I think, so first of all, I think it's impossible to stop the development. There's no way to outlaw engineering, not unfortunately. It's not possible. So we have to be more productive than this, unfortunately, or fortunately. Sorry, this is a hard one. Let's see. We can't tell scientists what to do. We've learned that. Scientists by nature are people who are alpha type. They go and do what they want. So telling them what to do doesn't work. It's the wrong kind of argument. What I think we can do is expose them to ethics and sociology and show them that there's real problems in the world and instill in them a desire to solve real problems. Because then they can make robots to solve pollution. They can make robots to solve communications issues, transportation issues, instead of concentrating on a technology for technology's sake. So I think we need this kind of problem-driven invention where people start to invent specifically for a problem that they're trying to solve in a community. What that requires is actually about funding. If you look at the way funding works in my country, the Department of Defense or a company sends out a request for proposals. They say, we want a robot that can do this, and they specify what it is. And the poor professors write to these proposals for money, and then when they get the money, they have to do exactly what the company said they have to do. So in a way, they're alpha, but they're also enslaved by the companies. The National Science Foundation that funds a lot of our work doesn't say, when you do robotics invention, we want you to have an ethical plan. We want you to show how the automation will not displace employment. How are you going to do job retraining? They don't say that in the proposal system, in the infrastructure for the proposal. And I think that's the disservice. So maybe what we need is a different way of setting up and managing the process of funding professors to do robotics research. That would be a step in the right direction.
It's a dreamer's question. Let me try to look to the future. And so maybe you can imagine the worst kind of things when the human will be on the planet Earth and the robots will be on the other planets, and they will be really researchers of the reality around. And do you believe in knowledge exchange between human and between robots? And maybe if you do, maybe you know some techniques in this area, or maybe you think the robots is just a extra sensor of human.
This is an excellent question. Other planets is a really good example because the distance between the Earth and other planets is so large that if you're going to go to a different planet and do science, you always want the robot to do more of the science, even more of the inquiry, even more of the deciding what to go and look at and how to make decisions. So it's a lovely question. At NASA, we work hard on making the robots in the future have more ability to do science. And yes, we probably face a future in which robots will do more of the exploration for us outside of the Earth than we do. That's probably coming. This will also happen underground. Robots that can go deeper underground, be more autonomous, and go under the water into very deep places like the Marianas Trench and explore for us. So robots can become explorers. I don't think there's anything wrong with that. It will happen. And so yeah, I think this is coming.
Thank you. And another question. In nowadays, some days ago, in ancient Greek, there were liberal arts. You know what it means, and what do you think? What can be the liberal arts for nowadays in the sense of robotics and mediocracy?
This is a good question also. In fact, some of the problem we have in engineering in general is that you can go to a lot of engineering schools now and not get a liberal arts background before engineering, which is interesting because you don't draw upon the kind of cultural history that humanity has created on the reflective side. And it's very easy then to go down and become a technologist without thinking about the relationship the technology has to the trajectory of history or to society and the way society functions. So I think there's always a place for liberal arts. As far as robotics goes, I think there are a lot of rules in the world of law that we need to think about law in a framework where we have accountability that is massively distributed amongst people because of robots, where you have your autonomous car and you pass control to yourself, and in between it crashes. And you say, no, 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 the robot was driving. And the robot says, no, 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 Illah was driving. I was done. And you try and figure out who's at fault, who's going to pay for the damage. So the law is a very big place where jurisprudence, the concept of rights that we as humans have around privacy, property, and accountability, all of that probably has to be rethought when we invent a new species that can act in our world and that can collect information on us.
Thank you for a wonderful conversation. I have a historical question. There was already a huge hype about robots in the middle of the last century, where probably everyone thought they would be able to communicate with robots in maybe a few decades, and the progress was much slower than we hoped. And what do you think? What if current optimistic prognosis will fail too, and we will have probably toys in next years?
Yeah, it's totally possible that we're being way too optimistic. And especially people who say we're going to have everything by 2045. I think it's very possible that we're too optimistic there. In the middle of 1900s, like 1950 to 1980, the optimism is interesting. If you look at the algorithms that people were developing for software, if you run those software algorithms today on fast computers, they work. So it's interesting. Computers were too slow for the ideas people were generating. That's not the problem we have now. Now the problem we have is the computer can do much. We're not sure how to use the power of the computer best to crunch the numbers and make the best decision. The place where we were really wrong is that people thought they'd make walking machines because we thought we were going to figure out how to make miniature motors with very high energy density, with high resilience, with small battery packs that hold a lot of power. And that was completely wrong. Battery technology, if you look at and kind of graph how it's improved, it's not exponential at all. We had the same battery technology for decades. And then it got a little bit better with nickel metal hydride and a little bit better with lithium iron phosphate. But it didn't ever go exponential or 10 times or 100 times. So energy and motor control have turned out to be much harder than people expected. Now, having said that, that doesn't stop cameras in the world from seeing us and doing much of what I talked about in terms of perception, in terms of understanding. But it can stop portable robots for a long time until we can understand energy better.
Насколько я понял, в искусственный интеллект вы пока не верите, что он возникнет в ближайшие 10, 20, 30, 50 лет. Я тогда перейду к такому вопросу, как проблема аватара. Насколько я знаю, текущие разработки позволяют воспринимать сознанию какой-то внешний манипулятор как свой собственный. То есть можно наладить обратную связь сознания и какой-то там деревяшки, какого-то робота, и человек будет воспринимать манипулятор либо какое-то другое механическое устройство как часть своего тела. И учитывая текущие разработки, можете вы сказать что-то подобное, то, что мы увидели в фильме «Аватар», когда оно сможет появиться? Когда человек… я добавлю к своему вопросу еще небольшую ремарку. Нейроинтерфейс у нас активно развивается, когда просто с помощью мысли человек может чем-то управлять. Может управлять простейшими манипуляторами, набирать мыслью какие-то слова на экране. И вот если появится симбиоз нейроинтерфейсов и таких механизмов, когда мы можем ожидать аватаров, реальных аватаров, которых мы видели в фильме Камерона?
So 2 quick things. One is, actually my PhD is in artificial intelligence. So I guess I must believe in artificial intelligence a little bit because I have a doctorate in it. But I don't believe in its success yet. Let's put it this way. Not in that full success. Avatars fundamentally require the ability to bidirectionally, 2 ways, manipulate the neurons in your brain. We have to be able to read them all very well, especially the brainstem, and we have to be able to send signals to them to get feedback from the avatars correctly. Otherwise, it's just a video game interface. I talk in my book about probably the only likely way of doing that being nanorobotics. And even with nanorobotics, you need something like 500 million robots to do this. And we have no idea how to do that yet. Using electroencephalography, EEG machines from the outside have been reasonable, but not good enough in terms of getting enough specific information to control robots. It doesn't give us feedback. People have tried putting electrodes in the brain, but it's, what do you call it, çerk in English? I know the Farsi word, did that help? It infects. It infects after a while. So you can't put electrodes inside the brain because of infection issues, and the neurons change pathways. So I think that's going to take many decades to figure out. We basically don't have direct control of brain, so we can manipulate it up with sensing and get motors out. The closest we can come right now is muscles. And last question.
Вопрос по-русски, да. Ну, не секрет, что разработки в области робототехники ведутся по многим направлениям, но есть ли какое-то магистральное направление, и согласны ли вы в выборе приоритетности, есть ли в этом проблема?
It's an excellent question. It's a good management question. The mainstream direction 25 years ago was industrial robotics. In other words, automation in plants where you're mass producing, let's say, cars or CD players, for those of you old enough to remember what a CD player is, like me. So that's where automation was concentrating before. Now it is actually fractured. There's medical robotics, which is a major push. We even have small robots that can do heart surgery. They sit on the surface of the heart, and as the heart beats, because they're going up and down with the heart, they can operate without stopping the heart, which is quite good. It's a big difference from the old days where you had to stop the heart and paralyze it to operate on the heart. So that's major. So we have medical robotics, which is a major push. We have haptics, which is the ability of people to use robotic systems to control very fine things. To, for instance, do micromanipulation, to reconnect a hand if it's been cut off, for example, or do an organ transplant at the very fine level. And then we have computer vision is a very, very important part of robotics right now. Probably the largest amount of money in my department. We have 70 professors of robotics in my department. The largest amount of money spent in my department is computer vision. I would say second largest amount is defense robots, unfortunately. So in the US, a huge amount of the gross domestic product goes toward military. And so military robots, basically robots for war, are a huge source of innovation in robotics today. In Europe, it's much more basic AI, understanding how the brain works, and using robots as a biological tool to understand the brain better. Thank you again all for your attention. It was an honor to be here.